Welcome to this video on how to tackle paper 2 of your ISA or CAU. We'll start with question 4. When you did the experiment, you plotted a graph, and this is worth 4 marks, so these are the things to look out for. On your graph, the x-axis is for the independent variable, the thing that you change. The y-axis is for the dependent variable, the thing that changes as a result of your changes and that you measure. Your points should cover at least 1/3 of the paper. Aim for half. If they don't and you find them all bunched up in one corner of the paper, then rescale your axis. You may not have to start at 0 if this is the case. So you can see, if we start from a non-zero point, 10 on the x-axis, this data fills the paper. Remember to label your axes, because without the labels you lose marks. With this sort of data, you should have a smooth, curved, best fit line. It's continuous, so it's a continuous variable. Avoid drawing a straight line if your points obviously fit a curve. If, on the other hand, your points seem to lie on a straight line, then use a ruler and draw a straight line. You're allowed to miss some points. If your data consists of categoric variables, then do not use a line, use a bar chart. And finally, check your plotting. You mustn't be any more than 1 millimeter off. Now we'll look at what you have to do in paper 2. Question 1. You may be asked something like, what were the variables, the independent, dependent, and control variables? This is a typical specimen paper question. The independent variable is what you control or change. In this example, it's the concentration of disinfectant. The dependent variable is what you measure. It could be the number of bacterial colonies that grow. It depends on what you did in the first place. Finally, the control variables are the other things that affect the experiment. Examples might be the temperature in the room or the types of disinfectants available to use. You would try and control the temperature for all your experiments, and you would try to use the same sort of disinfectant. Other types of variables that you might encounter include continuous variables and categoric variables. Continuous means that the numbers change smoothly. Categoric means you could name them, for example apples or pears. You may also be asked about repeats. You would need to explain why you need to take repeats. For example, there might be some odd or anomalous points that you encountered. Another reason why you need to take repeats might be there were background problems. For example, the temperature was different at different times of day. We often call these systematic errors or uncertainties. Then you need to give some more details about your readings. They may ask you about the range and whether it was appropriate. The range is from your lowest reading to your maximum value. And to judge if it was appropriate, is the range big enough to show a pattern with confidence? Again, you'd need to make a comment about this. And it's really important when you make a comment to give examples. Notice I've underlined the S. You need to give more than one example. If you don't have to talk about range, you may have to talk about resolution, the smallest divisions your equipment has, or the interval, the gaps between your measurements. You'll be asked if your results support the hypothesis, and you need to say something like, yes, my results support the hypothesis, as when I increase the concentration of disinfectant, the number of bacteria colonies decreases. Notice we're repeating the hypothesis and saying, yes, the results support it. If your results do not support the hypothesis, say so and give a reason. You may need to say that they show a pattern, like we have in this example, and you should explain how and include examples again. Sometimes you are given other people's results, and you need to talk about how the investigation is reproducible because other people's results match your own. You need to talk about the similar patterns they have to yours, or you might need to say how they get different results. Remember, you need to explain this, backing up your explanation with examples from your results and possibly the results you were shown. Next we have question 2. You are usually asked to sketch a graph showing things that you've been testing. In this case, we have the number of colonies of bacteria which depend on the concentration of disinfectant. Remember to label your axes. I'm drawing a curve over here showing that the number of colonies decreases as the concentration of disinfectant increases. You need to decide whether you use a curve or a straight line. Since it is a sketch, there should be no points and no numbers. You must make sure that the dependent variable is on the vertical axis and the independent variable is on the horizontal axis. Get these two variables right. You will be given a sheet of paper with about 4 case studies. You need to explain whether they support the hypothesis or not, giving examples. Usually, 3 of them are the same sort of experiment as the one you've done, but one of them is similar but it uses a different variable. Try and spot this early on. You'll probably need to describe some sort of relationship in your results or a case study and look out for patterns, and this will help you to make a conclusion giving examples. Use extra paper if you need, and write about all 4 sets of data. They may give you a conclusion, so comment on it, saying what you think and why, and you may need to use this conclusion to justify a claim or some advice given. For example, there may be a claim such as, this sort of disinfectant is better than that sort of disinfectant. Try and match it to the results you have been given or have found. It's very likely you'll need to describe one set of results in detail, and again remember to give examples. Lastly, you will do question 3, and this can be a little bit strange. They usually ask you, how could the results of your investigation be useful in the context you have researched? Here you are using your conclusion. You could say how manufacturers could choose the best or optimum concentration to use for people buying a disinfectant. In your conclusion, you're likely to have a number or an example value. Use it. And it links the manufacturers to people. That's the context you usually talk about. If you've followed the advice in my videos, you're likely to have got most of the marks. Good luck in your investigation.